Welcome everybody. This is 7.1 on trig identities. Your lesson objective for today is to simplify and to prove trig identities. Okay, trigonometric identities. To start off, you see this box right here. These are all the identities that we're going to use for today. Okay, so you got the reciprocal identity, cosecant, secant. There's a reciprocal of sine and cosine, so it's 1 over sine and 1 over cosine. Cotangent is 1 over tangent. Tangent is also sine over cosine, and cotangent is the reciprocal of tangent. So if you flip sine over cosine, you get cosine over sine. And these are the three Pythagorean identities we covered in our last chapter. Okay, so please get familiar with that. So we're just simplifying and we are proving trig identities. Okay, so first to simplify things. So number one, cosine plus tangent times sine of x. What we do here is we can use our identities, right? 8 of them to kind of simplify this. Okay, so if it's cosine plus tangent, cosine of x plus tangent of x times sine of x, we're gonna change tangent into using this one, number 4, sine of x over cosine of x, okay, times sine of x. All right. So here I just used tangent of x equals sine over cosine. Okay. So you can see that it's a change into that. Okay. And then we're going to simplify things. We're gathering the like terms, or not gathering the like terms, but we are going to multiply these two guys. So sine of x over cosine of x times sine of x over 1. We're going to multiply across. So that's sine squared x over sine times sine is sine squared over cosine of x times 1 is just cosine of x, right? And now we have this. And whenever we have a fraction, we can simplify it by getting our lowest common denominator, right? So here our LCD is cosine of x, okay? So if our LCD is cosine of x, in order for cosine of x, like a little sidebar here, in order for cosine of x to have a denominator of cosine of x, this has to be cosine of x times cosine of x, right? I'm going to be multiplying cosine of x from to top and bottom, making it into cosine squared x over cosine of x. Okay? So here we have cosine squared x plus sine squared x, because this one already has a denominator of cosine. Okay? We have cosine squared x plus sine squared x over cosine squared x. Right? And this actually was just a sidebar, so that you don't really need, but then I just showed it to you guys. Okay, so cosine squared x plus sine squared x, that looks really familiar, right? That's one of our Pythagorean identities up here. So that equals 1. So I'm going to turn that into 1. So cosine squared x plus sine squared x equals 1. I'm going to use that and then turn my numerator into 1 over cosine of x. 1 over cosine of x, if we look at our reciprocal identities again, 1 over cosine is actually secant. Okay? So that would be secant of x. So that's the way we would simplify this. Okay. Just take note that I turned everything into sine and cosine. That's one of our rules that we're going to cover. And whenever we have a fraction, we're always going to get our LCD. Okay, so those are the two little things that you have to kind of pick up for that problem. For this problem here, okay, we're going to simplify sine over cosine, sine of x over cosine of x, plus cosine of x over 1 plus sine of x, right? So I wrote it here again. And then, so I have two fractions, right? What we want to do is find our LCD. Our LCD here is just going to be the multiplication of the two, okay? Our LCD is cosine of x times 1 plus sine of x, okay? So here we can also do a sidebar, but I'm not. I'm just gonna go and do it. That's just gonna be all over cosine of x times 1 plus sine of x, okay? And please do not distribute it. Just leave it like this because that's a lot simpler. And then I think later down the line, we can cancel stuff out, okay? So you want to keep it um, as simple as possible, all right? So here, I always think, I have a denominator of cosine of x. That's this first fraction right here. This first fraction, cosine of x, has a denominator of cosine of x. But I do need a cosine of x times 1 plus sine of x, right? So here I have to multiply by, I'm going to multiply this by 1 plus sine of x, okay? But whatever I do to the bottom, I have to do to the top, 1 plus sine of x, right? So sine, so this would be sine times 1 plus sine of x, okay? And that plus becomes this plus. Here, I would need to multiply top and bottom by cosine of x, right? To get the same denominator of this. So here I would have cosine of x times cosine of x, okay? The denominator I want to keep as is. Here in my numerator, I am going to distribute that out, okay? I'm going to distribute the sign out. So that's sine of x. Sine of x plus sine squared x. Sine times 1 is sine x. Sine times sine is sine squared x. Plus cosine of x times cosine of x. That's cosine squared x, right? So I notice that I have, again, sine squared x plus cosine squared x, right? Sine squared x plus cosine squared x equals 1, right? So if it equals 1, then I can make this whole thing equal to 1, right? So this would be sine of x plus 1 over cosine of x times 1 plus sine of x, right? So 1 plus sine of x is the same thing as sine plus, or sine of x plus 1. So they would essentially just cancel out. Okay, whatever's on the top, yeah. So we have 1 over cosine of x, and again, that is secant of x. How fun, right? Because you guys know that this whole thing here, when you simplify it, that's just secant of x, okay? And this is what we're going to do when we prove it. All right, so here are some rules that you guys have to kind of follow along with, okay? Proving trigonometric identities, number one is we're going to start off with one side. Okay, we're going to pick one side of the equation, the more complicated side, okay, and your goal is to make it look like the other. Okay, for example, if I had this, going back to number two, right? I would pick one side of the equation, the more complicated side, and then make this guy look like this guy by doing this. This is my proof, right? Okay. Number two, use known identities and algebra, right? Um, to kind of put it together to kind of simplify it. When you have a fraction, you're going to use a common denominator, factor it out, and then simplify. And then step number three is to convert everything into sine and cosine, because every trig function can be turned into sine and cosine. All right, so that's the rules of this proving. And we're just going to go over three proofs. All right, so the first proof is here. Okay, we have cosine of x times secant of x minus cosine of x equals 1 or equals sine squared x, right? And obviously, this side right here is the more complicated side, right? So I am going to take that side, cosine of x times, and I'm going to turn everything into sine and cosine, okay? Secant of x is 1 over cosine of x minus cosine of x, okay? And you're going to go along that path and then simplify this side, hoping or keeping in mind that the other side is sine of x, sine squared of x, okay? So 1 over cosine minus cosine. This can be simplified because I have a fraction, right? I'm going to put it all under one denominator. So my lowest common denominator is cosine of x, right? 1 over cosine over 1. My LCD is cosine of x. So I can essentially put all of that under one denominator and say this is just 1, right? In order for this 1 to be cosine of x, I would have to multiply both top and bottom by cosine of x, right? Yeah, so 1 times cosine of x is now my denominator, cosine of x. Cosine times cosine, that would be minus cosine squared x, okay? All right, so wait, I see a 1 minus cosine squared x. Whenever I see a squared, remember, whenever I see a squared, I'm always thinking back to these trig identities, in particular these Pythagorean identities, okay? So notice that we have all of these squares, right? And I have 1 minus cosine. So I'm going to try and manipulate this to look like 1 minus cosine. So sine squared x plus cosine squared x equals 1. If I subtract cosine squared x to both sides, I would have sine squared x equals 1 minus cosine squared x, right? And since 1 minus cosine squared x is the same thing I have here, I can substitute sine squared x into this, okay? So I have cosine x times sine squared x over cosine of x, right? Sine squared x over cosine of x. Now I see cosines on the top and the bottom, when I multiply, those guys cancel out, and we're left with sine squared x. And as long as this guy is the same thing as this guy, right? It looks like the other side, right? Then you're good, okay? So this one here, we have 2 tangent of, of x times secant of x equals this complicated one here, right? So this side here is the more complicated side, right? More complex. So everything is in terms of sine and cosine. So I'm gonna just write it out again so I can work with it. Okay. I see 2 fractions. I'm gonna try and put them together with the common denominator. My common denominator here would be 1 plus sine of x times 1 minus sine of x, right? So that's my LCD. So that would be here. 1 plus sine of x times 1 minus sine of x. Okay? So if I have a denominator of 1 minus sine of x here, right, I would have to multiply both top and bottom here by 1 plus sine of x. And again, I multiply 1 plus sine of x because 1 plus sine of x times 1 minus sine of x is the same denominator here. Okay? So 1 plus sine of x times 1, that's 1 plus sine of x, right? And here, if I have the denominator of 1 plus sine of x, and I want the denominator to be this, I would have to multiply this by 1 minus sine of x, right? So now 1 plus sine of x times 1 minus sine of x is the same thing, the same denominator we have here, okay? There's a minus sign in between, and 1 times 1 minus sine of x, 1 times 1 minus sine of x is 1 minus sine of x, okay? These parentheses are important because you have a minus sign on the outside, okay? So my next step would be to distribute. So just distribute and simplify. Okay, that's what I'm gonna do next. All right. So here, I'm gonna distribute out the negative to both the 1 and the negative sine of x. So I have 1 plus sine of x minus 1, and then minus a negative is plus sine of x over 1 plus sine of x times 1 minus sine of x, right? So 1 minus 1, they cancel out. I have sine of x and a sine of x, so I have 2 sine of x, right? 2 times sine of x over. Now, do you notice something in my denominator? They are actually difference of squares, okay? And remember, the difference of squares is actually a plus b times a minus b. That will always break down into a squared minus b squared. Okay, so a is 1 in this case, and b is sine of x. So a squared minus b squared, that would be 1 minus sine squared x. Okay, you guys see that? Hopefully you guys do. And so what is 1 minus sine squared x? Again, light bulb, right? I see a sine squared x, so I automatically convert it to this, right? My mind goes here with the Pythagorean identities. It's number 1 that I'm going to use. So number 1, it says sine squared x plus cosine squared x equals 1. If I subtract sine squared x, right, then I would have cosine squared x equals 1 minus sine squared x, right? So I can convert this into cosine squared x. 2 times cosine, or sine, I'm sorry, sine of x, right? So 2 times sine of x over cosine squared x. Now, you might be thinking, now what, right? So if we do a little bit of tricky algebra, okay, I'm gonna just write that down here, okay? 2 sine of x over cosine squared x, right? Since this is squared, now, I can put this as 2 sine of x over cosine of x times cosine of x, just splitting up the denominators, right? Okay, so this would be a big 2 sine of x over cosine of x times 1 over cosine of x. Okay, the reason why I'm doing that is because I have the other side in mind. Okay, I started off with this side, remember, right? And I got all the way to here. But I got 2 tangent of x, secant of x, okay, with tangent and secant. Okay, so you just keep that in mind, tangent and secant, tangent and secant. So here, what is sine over cosine? Well, that is tangent. What is 1 over cosine? Well, that is secant. Okay, so that, since that guy equals my right-hand side, we're good. All right, so that's another trick. If you see a squared on the bottom and you're stuck, go back to your proof. Because sometimes when you're in the middle of it, you don't know what your goal is, right? And your goal is to put it into tangent and secant, okay? So, okay, I know sine over cosine is tangent, so just split it up, right? And just do that math, all right? Last one of the day is this one here. Cosine of x over 1 minus sine of x equals secant of x plus tangent of x. In this case here, we have, what's my more complicated side? I would say the fraction. Okay, that's more complicated, right? MC, more complicated. So I'm gonna start off here. Cosine of x over 1 minus sine of x. Okay, I have no idea. Everything's in terms of sine and cosine. So always keep in mind the difference of squares. Okay, a squared minus b squared equals a plus b times a minus c. Just to do it so I can use the Pythagorean identities. Okay, so here I'm going to multiply both. Since I have 1 minus sine of x, I'm going to multiply it by 1 plus sine of x, the conjugate, right? Of sine of x, okay? So when I do that, be in mind that it's secant times tangent. Okay, in my numerator, I have cosine of x times 1 plus sine of x over 1 minus sine of x plus times 1 plus sine of x. That would be 1 minus sine squared x, right? And remember, 1 plus minus sine squared x equals cosine squared x. So I can put that cosine of x times 1 plus sine of x over cosine squared x, right? What I used is cosine squared x equals 1 minus sine squared x. Okay, using the Pythagorean theorem or Pythagorean identity of sine squared x plus cosine squared x equals 1. Okay, so we got that. We're good with that. And now when I look at it, I'm going to simplify this. 1 cosine of x. I'm going to take away one of these cosine of x. Okay, so what we have, they just cancel out, is 1 plus sine of x over cosine of x, right? Now, algebraically, right, this denominator here goes to both the 1 and the sine of x, okay? So I'm going to split that up, kind of hoping that my answer comes out. So it's a 1 plus sine of x, okay? Right, you guys can see that this equals this whole thing, right? What is 1 over cosine? Well, that is secant of x. Sine over cosine, that is tangent of x. So, since I have the same right-hand side, I am good. All right, so that's the lesson on 7.1, and that's the introduction to proving trig identities.